So in the last class we discussed how to form a differential equation, what will be the order of differential equation and what will be the degree of differential equation. Today we shall discuss the solution of differential equation of first order and first degree. First order means it is having only dy by dx. First degree means the variables are only one. So that type of equations are called first order and first degree differential equation, right? There are two methods. One is variable separable method, other one is linear differential equations solutions, right? First we shall discuss the variable separable form, variable separable method of getting solution of given differential equation, right? Variable separable method, right? See, there is a function like x square plus y square is equal to a square. If the function is differentiated, 2x plus 2y into dy by dx is equal to 0, right? Differential equation will be formed. This is said to be what? Differential equation. Now, using differential equation, we have to get its solution or its root. That is called as solving the given differential equation. From the function, if you differentiate it, you will get the differential equation, right? From the differential equation, we have to go in the reverse direction. In the reverse direction to get the solution. The reverse direction of differentiation is what? The reverse process of differentiation. It is called as integration. Correct? Any given differential equation, it is differentiation, you will get differential equation. Any differential equation, if it is integrated, you will be getting function, right? This is called as solution, solving of differential equation. So given differential equation cannot be integrated directly. Some equation can be integrated directly, some cannot be. Why? Because they will be in different form. They will be in mixed variable form. X should be along with dx, y should be along with dy. Then only we can integrate it. Otherwise, we cannot integrate. Therefore, we have to use a step to separate the variables. Variables means x, y, z, theta. They should be separated with respect to their variable. X terms are collected along with dx, y terms are collected along with dy, z terms are collected along with dz, like that. Then we have to go for integration, right? The variable separable method, the given differential equation is reduced to the form of f of x dx is equal to g of y dy. See, after taking certain procedure, the given differential equation should be reduced to this form. What is this form? See, all x terms are collected along with dx. All y terms are collected along with dy. Means all x are separated, all y's are separated. That is called as variable separable form. It is called variable separable form. Then we have to integrate. That is integration of f of x dx is equal to integration of g of y dy plus c is the solution of the given differential equation using variable separable method, right? What is the steps we need to follow? First thing is we have to separate all the variables with respective to the dx and dy. It should be reduced to this form. X variables are separated, y variables are separated. This form will be called as variable separable form. Then we have to go for integration. Only two steps we have to follow. First step is to separate the variables. Second step is to integrate the separated variables. That is known as variable separable method. Problem will be like this. They will give you solve. They will give you only solve. They will not mention you solve it by variable separable method or some other method. You have to understand the problem, in which method we need to follow it to get its solution, right? Solve. Number 1, x dx plus y dy is equal to 0. I've taken very simple problem. What is that problem? X into dx plus y into dy is equal to 0. You observe this. Can we separate the variable? Not required. Why? The given function or the given differential equation is itself in the separated form, right? See, x is along with dx, y is along with dy. Don't think that we should be always in this form, right? So this may be the plus or minus or is equal to symbol. Okay. See, all x are collected with dx plus or minus or is equal to all y should be collected with dy. This is called as variable separable form. It is variable separable form. Then integrating x into dx plus integrating y into dy is equal to c. Constant of integration. What is integration of x? It is x square by 2 plus what is integration of y? It is y square by 2 is equal to c. So we have 2 at the both the denominators. I can multiply with 2. If I multiply this with 2, I will get only x square. If I multiply this with 2, I will get y square. This become what? 2c. C is constant. Correct? 2c means it is 2 times of constant. What it is? You are getting again constant. Therefore, 2c, 3c, 5c, it is considered as some constant. Therefore, we don't put in the form of 2c. We will put in the form of only c. C means constant of integration. It may be 2 times of previous constant or it may be half of the constant, something else, right? This is called as solution of the given differential equation, right? Next one, y into dy by dx is equal to 3x plus 2. Solve the differential equation. Y into dy by dx is equal to 3x plus 2. So our intention is to separate the variable. See, y dy by dx. Can you send this dx to other side? If I send the denominator dx to the right side numerator, it becomes y into dy is equal to 3x plus 2 into dx. This is what? The given differential equation is reduced to which form? X, all x, it may be plus or minus constant with dx. Y with dy, we will call it is variable separable form, right? See, in the left side, do you find any x term? No. At the right side, do you find any y term? No. Hence, we say that this is variable separable form. Then integrate. By integrating y into dy is equal to integration of 3x plus 2 into dx plus c. I've taken just integration symbol on both sides. Okay. Integration of y with respect to dy. It is similar to x only. It is x square by 2. X square by 2. Correct? For x, it is x square by 2. Similarly, for y, it is y square by 2 is equal to integration of 3 into x. For x, it is x square by 2. Plus for 2, it is 2x plus c. So integration is over. So this will be the solution of this differential equation, or we can put it in other form. Just multiply by 2 on both the sides to remove the denominators, right? Y square by 2 into 2 is what? Into 2, it is y square is equal to 3x square by 2 into 2, 3x square plus 2 into 2, it is 4x plus 2 into c, 2c. As I mentioned that any constant, any numerical times of c can also be taken as what? Only c. That becomes y square minus 3x square minus 4x is equal to c. Or you can also write like this, multiplying by minus sign. Minus sign. This become minus, this become plus. 3x square minus y square minus into minus plus 4x. This will become what? Minus c. So minus c can also be taken as c only. Therefore, it is 3x square minus y square plus 4x is equal to c. Minus c, 2c, 3c, 5c, they are all what? They are all the constants only. Finally, we will write only in terms of c, that is constant of integration. Five x plus y into dy by dx is equal to 7. Next problem is 5x plus y into dy by dx is equal to 7. See, here also it is similar to the previous example. Here we cannot send this dx directly towards right hand side because there is a sum of another term. What to do? First, that x term if is to be sent to the right side, transferred to the right side. Okay, this is taken like this: y into dy by dx is equal to 7. 5x, if it is sent to the transferred to the right side, whose sign become opposite, that is 7 minus 5x. Okay, now it is easy to transfer or cross multiply to the, so y is equal to 5x into what? dx. It is variable separable form. See, is there any x term here? No. Therefore, it is separated. Y term is separated with dy. Right side, do you find any y term? No. Along with dx, there is no y term at all. Hence, it will be the x only. It is separated with its variable. Therefore, integrate. On integrating, it becomes integration of y into dy is equal to, for constant, it is constant into x minus 5 into x square divided by 2 plus c. You take all these to this side. Sorry, I have just integration part I have written. First write symbol, then we can integrate it. Okay, plus c. Integration of y, it is y square by 2 is equal to integration of constant, it is 7 into x minus 5 into, for x it is what? X square by 2 plus c. Take these two terms to the left side. Minus becomes what? Plus 5x square by 2. Then write y square term plus y square by 2. 7x, when it is transferred to the left side, it becomes minus 7 is equal to c. Now just multiply with 2. 2 into this, 2 to cancel. 5x square plus 2 to cancel. Y square minus 2 into 7. 14x is equal to 2c. So 2c can be taken as what? C only. So solution is 5x square plus y square minus 14x is equal to c. This is known as the solution for the given differential equation. Sometimes they need complete solution for the differential equation. It means what? For all those problems just now found the solutions, their solutions are incomplete. How we can say it is incomplete? Because at the end we take c value. What is c? C is unknown. It is any constant, right? Therefore, to get complete solution, sometime they will give you the x value and y value. See this. Solve 2x minus 3y into dy by dx is equal to 4 at x is equal to 1 and x is equal to 2. Sorry, y is equal to 2. Sometimes they will give you the point x and y at which we need the complete solution of the differential equation. Then how it is to be integrated, or we cannot integrate as it is because the variables are in combined form, right? Therefore, what to do? You just send minus 2x, plus 2x to the right side. It become what? Minus 3y into dy by dx is equal to 4 minus 2x, right? Then just send this dx to the right side. Cross multiply it. Now this become what? Variable separable form. Only y with dy, only x with dx. Constant may be included for x or y, right? It is variable separable form. Integrated. Integration of minus 3y is equal to into minus 2x into dx plus c. So c is very important, that is constant of integration. Okay. In usual procedure, integrate it. Minus 3 for integration of y is what? Y square by 2 is equal to, for constant it is 4x minus 2. For x it is what? X square by 2 plus c. So 2 to get cancelled, right? You take this to the right side, minus x square become what? Plus x square minus 3 y square divided by 2. Then the 4x can also be transferred to the left side. It is minus 4x is equal to c. This is the solution. It is solution, right? But we need solution at x is equal to 1 and y is equal to 2. So these values of x and y are given to get c. If I substitute c value particularly, so this will become complete solution, right? Put x is equal to 1 and y is equal to 2 to get c. Therefore, 1 square minus 3 into 2 square divided by 2 minus 4 into 1 is equal to c. 2 to get cancelled, correct? 2 square is 4, 4 by 2 is 2. It is 1 square. 1 square is what? 1. 1 minus 3 into 2, 6 minus 4 into 1, 4 is equal to c. Or c is equal to, what is c? 1 minus 10. 1 minus 10 is what? Minus 9. Minus 9. Therefore, the solution is what is solution? X square minus 3y square divided by 2 minus 4x is equal to minus 9. Or you can take it as x square minus 3y square divided by 2 minus 4x. If I take minus 9 to this side, it becomes plus 9 is equal to 0. This is the solution of the given differential equation. It will be called as complete solution, right? Next, let us take some other examples. X into dy plus y into dx is equal to 0. We have taken another simple example, x into dy plus y into dx. See, this differential equation is not in the normal case. In all previous examples, just by shifting one term to the right side or left side and cross multiplying dx, it will be the standard form. But here, not in that case. Okay, the case may be different. X into dy plus y into dx is equal to 0. See, along with the dy, we have x term. Along with the dx, we have y term. Those unwanted terms. Here, we should have y term, but there is x. That should be removed. Here, we have y. It should be x or in x term. So, y should be removed it. So, I say this is unwanted term here. This is unwanted term here. Then how to remove those unwanted terms? The simple method I tell you, the whole given differential equation is to be divided with the product of unwanted term at x, dx and dy. What I said, you take the unwanted terms, make the product, and that product is to be divided for all the terms in the given differential equation. Automatically it will reduce it to the variable separable form. Okay, what is unwanted term at dy? X. What is unwanted term at dx? It will be said y. So divide by product of what? Xy on both sides. Divide by xy on both sides. That is x by dy divided by what? Xy plus y into dx divided by xy is equal to 0 by xy. Make a product of unwanted terms at dx dy. Divide with every term of the given differential equation. Now cancel the common terms at numerator and denominator. Here x cancelled. Here y cancelled. 0 by anything is what? It is 0. Now it becomes 1 by y dy plus 1 by x dx is equal to 0. Right? Now check the reduced form of differential equation. Here we have only y terms. Here we have only x terms along with dx. Say it is variable separable form. It is variable separable form, right? So integrate it. On integration, 1 by y into dy plus integration of 1 by x dx is equal to c. C is constant of integration, right? What is integration of 1 by x with respect to dx? With respect to x is log x. In the same way, 1 by y with respect to dy will be taken as log y, right? It is log y plus log x is equal to c. What is c? C is constant, right? I will take constant in other form, log C. Why I am taking log C? In all the previous examples, I took only C. Everything is taken in terms of C only. But here I am taking in terms of log C because at the left side we have both the terms in log. So if this is the case, if the solution get it in log, then you take right side instead of C, take log C. Take log C. Because this will help you to simplify further. Okay. This log y plus log x, it is of what form? As we know that log mn is equal to log m plus log n. Is it right? Log m by n is equal to log m by n is equal to log m minus log n. So use these formulas to for simplification further, right? Log y plus log x is equal to what? Log of y into x is equal to log of what? C. So log C is also constant. You can consider it of any form of constant. Okay. Now taking anti-log on both sides. Taking anti-log on both sides. This log and this log be removed. They will become vanish. Only thing is x into y is equal to C. This is the solution of differential equation, right? At the same time, let us take some other equations. Sin square x into dy plus sin square y into dx is equal to 0. As I said, if there is a x term with dy, y term with dx, we have to separate it. So it is in mixed form. Along with x term there is dy, along with y term there is dx. How to separate it? As I mentioned that divide by the product of unwanted terms at dx and dy, which is unwanted here, along with dy, this is unwanted, sin square x into, along with dx, what is unwanted term? Sin square y is unwanted term on both the sides, right? That is sin square x into dy all divided by sin square x into sin square y plus sin square y into dx all divided by sin square x into sin square y is equal to 0 by anything is equal to 0 only, right? One sin square x cancel, sin square y cancel. What is remaining? 1 by sin square y into dy plus 1 by sin square x into dx is equal to 0. Now check the reduced form. Is it in separated form? Right, it is in separated form. Along with dy, we have only y term. Along with dx, we have only x term. We can further simplify it. What is 1 by sin? 1 by sin a can be taken as cosecant a. That is 1 by sin square is cosecant square y into dy plus 1 by sin square x is cosecant square x into dx is equal to 0. It is variable separable form. Integrated. Integration of cosecant square y dy plus integration of cosecant square x dx is equal to c. C is what? It is constant of integration, right? What is integration of cosecant square x? It is minus cot x, right? So according to that, it is minus cot y plus minus cot x is equal to c, or I can write by multiplying minus sign, minus of minus, plus cot y plus cot x is equal to minus c. Minus c can be taken as only c. This is cot x plus cot y is equal to c, right? Next problem. 1 plus or minus x into dy plus 1 minus y into dx is equal to 0. 1 minus x into dx plus 1 minus y into dy is equal to 0. Along with dy, this whole bracket is unwanted. So I cannot multiply this. So dy minus x into dx. I can keep this as it is. In the same way, I can keep this as it is, dx minus y into dy. So it is difficult to separate it. You do one thing, take whole bracket will be unwanted. See, there is a constant. You may retain it or you can remove it. No problem. You take complete. This is unwanted along with dy. This is unwanted along with dx. Right? This should be removed. This should be removed. Therefore, divide by what? 1 minus x into 1 minus y on both sides. You just multiply, divide with the product of unwanted terms at dx and dy. Then we get what? 1 minus x into dy all divided by what? 1 minus x into 1 minus y plus 1 minus y into dx 1 minus x into 1 minus y is equal to 0. 0 by anything is 0, right? 1 minus x cancel. 1 minus y cancel. What is remaining? 1 by 1 minus y into dy plus 1 by 1 minus x into dx is equal to 0. Now check this. It is in the variable separable form, right? It is variable separable form. Then integrate it. On integrating, see 1 by 1 minus y into dy plus integration of 1 by 1 minus x into dx is equal to c. C is constant of integration. What is integration of 1 by 1 minus x? As we know that integration of 1 by x is what? Log x, correct? So it is of in the same form. Direct substitution method. 1 by ax plus b dx is what? 1 by ax plus b form, right? It is of log of ax plus b divided by x coefficient. X coefficient is a, right? So use the same formula here. It becomes log of 1 minus y divided by, what is y coefficient? Minus 1. Plus log of 1 minus x divided by minus 1 is equal to, see both are in logs, correct? The right hand side is taken in terms of log c. Just multiply by minus 1. Multiply by minus 1. So it become what? Minus into minus, log of 1 minus y plus minus 1 cancels, log of 1 minus x is equal to minus log c. That minus log c can also be taken as what? Only log c, right? Log a plus log b is equal to log m, ab. Log m plus log n is equal to log mn. According to that, log of 1 minus y into 1 minus x is equal to log of c. By taking anti-log, it will become 1 minus x into 1 minus y is equal to c. That's the solution. Okay. See, the same problem will be given in this form. Solve dy by dx is equal to 1 minus y by 1 minus x. Or it will be given like that. Dy by dx plus or minus 1 minus y by 1 minus x is equal to 0. They may give you plus or minus any one, right? If it is the case, you just cross multiply these two. It will become standard form, right? If it is plus, you take this term to the right side. It becomes what? Minus of this. Then just cross multiply these, so it will become variable separable form. If it is minus, by taking to the right side, it will become what? Plus. Just interchange these two, right? Among these three, I will show any one, right? Dy by dx plus 1 minus y by 1 minus x is equal to 0. I am taking this one. You may have negative sign here, or you may have is equal to sign. Okay. Then first you make, if it is positive or negative, you take the term to the right side. Separate dy by dx and separate the other terms. See, dy by dx is equal to minus, plus become what? Minus 1 minus y by 1 minus x. Right? It is very simple to make variable separable form. We can interchange these two. Can we interchange? So there is a provision in mathematics, we can cross multiply, right? This into this is equal to this into this. I am just interchanging denominator of first and the numerator of second. It will be in this form. See, dy by 1 minus y is equal to minus of dx divided by 1 minus x. I said interchanging denominator of first and numerator of second term. First term is left hand side, second term is right hand side. By doing that, it will become variable separable form. See, is it not variable separable form? It is variable separable form. Integrate it. Or integration of 1 by 1 minus y into dy is equal to minus of integration of 1 minus x into dx plus c. What is integration of 1 by 1 minus y? It is like previous example, no? Same. Take log of 1 minus y divided by minus 1 is equal to minus of log of 1 minus x divided by minus 1 plus c. So this minus cancel. I am taking, this is here only log of 1 minus x. This is what? Minus. When it is taken to the right side, it become what? Plus log of 1 minus y is equal to, you will get c, minus c. So minus t, minus c, I will take it as log c. Right? Log m plus log n is what? Log m plus log n is equal to log mn. Log mn. Log of 1 minus x into 1 minus y is equal to log c. So by taking anti-log, these two vanish. Remaining is 1 minus x into 1 minus y is equal to c. Right? Same procedure you can follow for these two. Dy by dx minus 1 minus y by 1 minus x, or dy by dx is equal to 1 minus y by 1 minus x. Right? Next problem, root of 1 minus y square into dx plus root of 1 minus x square into dy. Check the given differential equation. Along with dx, what is there? It is root of 1 minus y square. This is root of 1 minus x square along with dy. So, both the roots are unwanted term at first term and second term. It will be 0. Therefore, divide by what? Product of 1 minus y square and 1 minus x square. On both sides, it becomes root of 1 minus y square into dx all divided by root of 1 minus x square into root of 1 minus y square plus root of 1 minus x square divided by root of 1 minus x square into root of 1 minus y square into dy is equal to 0. 1 minus y square, 1 minus y square, they get cancelled. Along with root of 1 minus x square, root of 1 minus x square, they get cancelled. What is remaining? 1 by root of 1 minus x square into dx plus 1 by root of 1 minus y square into dy is equal to 0. Now check this state. It is of variable separable form, right? It is variable separable form. It is variable separable form. Then integrate. Integrate this. Integration of 1 by root of 1 minus x square dx plus integration of 1 by root of 1 minus y square dy is equal to c. What is integration of 1 by root of 1 minus x square? It is derivative of what? It is derivative of sin inverse x, correct? Therefore, integration of this is what? Sin inverse x plus sin inverse y is equal to c, right? This is the answer. The same question will be asked in this form. Solve dy by dx is equal to root of 1 minus y square by 1 minus x square, or dy by dx plus or minus root of 1 minus y square by 1 minus x square is equal to 0. As I mentioned in the previous example, you follow the same procedure. First, you take to the right side. If it is given plus or minus, you take it to the right side. Then just interchange numerator of second and denominator of first. It will reduce to the integral variable separable form. If I integrate it, you will be getting in the same answer. Sin inverse x plus or minus sin inverse y is equal to constant, right? One plus y square into dx plus x square plus 1 into dy is equal to 0. Check this. Along with dx, what is given? 1 plus y square. This is unwanted here, right? Along with dy, this is unwanted. Make their product and divide on both sides. Divide by 1 minus y square, 1 plus y square into x square plus 1 on both sides. On both sides, you will get 1 plus y square divided by 1 plus y square into x square plus 1 into dx plus x square plus 1 divided by 1 plus y square into x square plus 1 into what? Dy is equal to 0, right? Then the common terms at numerator and denominator, they get cancelled. 1 plus y square, 1 plus y square cancel. These two cancel. What is remaining? 1 by x square plus 1 into dx plus 1 by 1 plus y square into dy is equal to 0. It is variable separable form. Then integrate or integrating. This is 1 by 1 plus x square or x square plus 1. One and the same. I am taking into standard form. 1 by 1 plus y square dy is equal to c. Right? On integrating, what is integration of 1 by 1 plus x square? It is tan inverse x, correct? Plus tan inverse y is equal to c. The same question will be given like this. Solve dy by dx is equal to 1 plus y square by 1 minus y square, or solve dy by dx plus or minus 1 plus y square divided by 1 plus x square is equal to 0. So this is also solved like previous example. Okay. Next problem, x minus x into y square dx plus y minus y into x square into dy is equal to 0. See the example. This is of different problem when compared to the previous ones. Here x, y are mixed, correct? By looking into the problem, see the first one. What is there? X minus xy square. So x is common. Can you take x separate? You can take it as common. Here also y and y is there. You can make it separate. If I take minus y is common, you will be getting 1 minus x square, right? The problem is reduced to 1 minus y square into dy x into 1 minus y square into dy plus, here I will take y common, 1 minus x square into dy is equal to 0. Now identify the unwanted terms at dx and dy. At dx, which is unwanted term, this whole bracket, because x is there along with dx, let it be, you just remove this bracket. Here y and dy, keep it as it is, remove this. So divide by what? 1 minus x square into 1 minus y square on both sides. On both sides. We get what? By cancelling this and this, you will have x divided by 1 minus x square into dx, correct? Plus on cancelling 1 minus x square, 1 minus x square, remaining is what? Y into dy divided by what? 1 minus y square is equal to 0. It is what? It is variable separable form. Then we go for integration. On integrating, it become x by 1 minus x square dx plus integration of y by 1 minus y square dy is equal to 6. How to integrate this? What is the procedure we have to follow? It is not an ordinary integral like previous examples. Here x by 1 minus x square, y by 1 minus y square. So there is x square term and x term. Product of quotient of like that will be solved by what? Substitution method, correct? So here you take t is equal to, put t is equal to 1 minus x square. Differentiate this, dt is equal to 0 minus 2x into dx. Put 1 minus x square as t. Then Here I need only x into dx, correct? What is remaining? What is remaining? Minus 2. You take it this side. Minus dt by 2 is equal to x into dx. At the same time, in this integral, put s is equal to 1 minus y square. You take any another variable, right? Differentiate it. On differentiating with respect to y, 0 minus 2y into dy. Or this become what? Minus ds by 2 is equal to y into dy. The whole problem will be in other variables. This problem become what? Integration of 1 by 1 minus x square can be taken as 1 by t into x dx can be taken as x dx can be taken as what? Minus dt divided by 2 plus here also integration of 1 by s into minus ds divided by 2 is equal to c. Right? You take minus 1 by 2 outside. Integration of 1 by x. Integration of 1 by x is log x. Like that, integration of 1 by t is what? It is log t. Plus, you take minus 1 by 2 outside. Integration of 1 by s is what? It is log s is equal to, I will take it log c. Because both are in log. Now, I am multiplying with minus 2. All the terms are multiplied with minus 2. Then minus 2 get cancelled. It will be log t plus this is log s is equal to log of c. Minus 2 will be minus 2 into log c. So I am taking only log c, or it is what? Log of t into s is equal to log c. Or taking anti-log on both sides, it become what? T into s is equal to c. What is t? 1 minus x square. What is s? 1 minus y square is equal to c. So like that we can solve by substitution method, right? So these are the problems related to variable separable form. Okay. Then let us move to the another method of solving differential equation, that is linear differential equation. Linear differential equation. So it is little bit different than the problems we worked in the previous section, that is variable separable form. Linear differential equation. See, the differential equation of the form dy by dx plus y into p is equal to q. Dy by dx plus y into p or p into y is equal to q, where p and q are functions of x, and it is called linear differential equation. Linear differential equation of variable x. Sometime it will be reversed. dx by dy plus x into p is equal to q. In that case, p and q are the functions of y, right? So I will give you the solution for this first, right? This is the differential equation, linear differential equation. There is a solution for that differential equation. There is a standard form of solution. So the solution of linear differential equation is given by, it is standard one, or we can derive it. You just remember the standard solution for linear differential equation is y into if is equal to integral of q into if into dx plus c. y into if is equal to integral of q into if into dx. So y it is variable, q it should be taken from the given differential equation. We are having new term, that is if. So if is the new term which will be called as if is called integrating factor. If is what? Integrating factor. That we have to find out first. Integrating factor is to be found first. So what is integrating factor? It is equal to e to the power of integration of p dx. E to the power of integration of p dx. What is p? P is this. It is taken from the given differential equation. After getting this if, it is substituted here. Y is same thing. If is found from the differential equation and formula, that is to be substituted. Q is taken from the differential equation. If it is taken from this, and this has to be integrated. That gives you the solution of this linear differential equation, right? Sometime the equation will be given in reverse form, right? dy by dx is done, so there will be dx by dy form. See, like this, the differential equation is of this form: dx divided by dy plus x into p is equal to q. P and q are what? Functions of y. Then the solution is what? The solution is x into if, not y. Integration of q into if into not dx. We should write dy plus c. What is if? If is integrating factor. It is integration of e to the power of integration of p into dy, because p, q are in y, right? So most of the cases they will give you in this form only, right? Sometime if they give in the x variable form, y variable form, you take the suitable formula, right? Note, this is very important formula. Note. So e to the power of integration of p dx. While solving this, you will come across this form: e to the power of log a. There is a rule, there is a theorem. We can prove it as only a. E log they get vanishes. Only thing a will be the answer. See, example: integration of log of x is equal to only x, because base is what? Base will be e only. E to the power of log of secant x. So this becomes only secant x. E to the power of log of sin x. It will become only sin x, right? E to the power of m log n. If it is the case, it is to be made as log of n to the power of n. Log m log n is equal to what? E to the power of log n power m. Then e log cancels. N to the power of m will be the answer, right? These points are very important in getting integrating factor, right? Let us work out few problems based on the linear differential equation. So the problems we discuss here, they are most important for your examination point of view, right? Same problem will be repeated many times in many years, right? Here also they will mention like this: solve dy by dx plus y into tan x is equal to 2 secant x. By looking into the problem, it will come to know dy by dx plus y into p is equal to q. we cannot separate this. See how we cannot separate it? We have to take LCM because dx is only for this. If I take this is to this side, then along with this we will have plus or minus dy by dx. It is hardly difficult to separate into variable separable form, right? So therefore, it is easy to follow this linear differential equation method, right? First, identify or compare this with standard form. What is standard form? Dy by dx plus y into p is equal to q. Therefore, this is p, right? This is q. What is p? P will be the tan x. What is q? Q will be the 2 secant x. Therefore, first get the integrating factor. Before writing solution, you find out integrating factor. What is integrating factor? It is e to the power of integral of p dx, that is equal to e to the power of integral of p. What is p? Tan x into dx. Integration of tan x is what? Log of secant x. Is it right? E log cancels, only secant x will remains. That will be the integrating factor. What is integrating factor? It is it is secant x. Right. After knowing that, get the solution. Solution of linear differential equation is y into if is equal to integral of q into if into dx plus c. This you need to remember it, right? Y into if is equal to integral of q into if into dx. Just substitute the values of q and if. That's all. Y into what is if? Secant x. Integration of q. What is q? Q is 2 secant x. Into what is if? If is also secant x into dx. How do you integrate this? See, this is kept as it is. Y into secant x is equal to, you take 2 outside. What is remaining? Secant x into secant x. Secant x into secant x is what? Secant square x dx. Right? What is integration of secant square x? It is 2 tan x plus c. Therefore, the solution is y into secant x is equal to 2 tan x plus c. Same problem will be given. Instead of 2 secant x, they will give you 3 or 4 or 5 into what? They will give you cos x. If it is cos x, it becomes what? Secant into cos is 1. If is secant x. This is cos. Cos into secant will be 1. There the integration will come. For integration it is 1 only. For integration of 1 is what? X. Right? So they may be given in 2 ways. Same problem. At the right side, it will be given in secant or it will be given in cos. So I have done for secant. You just solve for the cos. Okay. I will show you in other examples of that type. See this. Solve. Sin x into dy by dx plus y into cos x is equal to 4. To make this into standard form, what is standard form? It should start with dy by dx. What about here? It is started with what? X term, sin x. So same type we did in the variable separable form. There will be a y term along with dy by dx. Then it is easy to transfer this to the right side. But here, along with dy by dx, there is a sin x term. If it is x term, this has to be solved by what? Linear differential equation form. You just remove it. How to remove this? just divide by sin x on both sides. On dividing sin x like this, sin x into dy by dx by sin x, y into cos x divided by sin x is equal to 4 by sin x. Sin get cancelled in the first term. What is remaining? Y divided by, dy by dx plus y into, what is cos x by sin x? It is cot x, right? 4 into 1 by sin x is what? 1 by sin x is cosecant x. Right? Now, this is the standard form, right? What is P? This is P. What is Q? This is Q. Get IF. IF is equal to e to the power of integration of P dx. Integration of what is P? Cot x dx. That is equal to e to the power of, for cot x. For cot x, it is log of sin x, right? E log cancels, only sin x will be the remaining. So that will be called as what? Integrating factor. So after knowing integrating factor, write the solution. Solution is what? Y into IF is equal to integration of Q into IF into dx plus C. Y into IF. IF is what? Sin x is equal to, what is Q? What is Q? Integration of Q. Q is 4 cosecant x, right? Into IF. IF is sin x into dx plus C. Cosecant x into sin x, it is 1, right? Cos x into secant x is 1. Tan x into cot x is 1. Suppose if you have the combination of like this, you take it as 1. Sin into cosecant 1. Tan into cot is 1. Cos into secant is 1. Therefore, it become what? Y into sin x is equal to, take 4 outside. Cosecant x into sin x is 1 into dx plus C, or it is equal to 4 into, what is integration of 1? It is x plus C. Okay. So this is y into sin x is equal to 4x plus C. 4x plus C. Right? So these two problems are very important. Next one, x into dy by dx plus y is equal to x sin x. X sin x. Right? X dy by dx plus y is equal to x into sin x. Take this as the differential equation here. So along with dy by dx, there is an x term. You first remove it. What? Divide by x on both sides. We get dividing this with x, you will be getting dy by dx plus dividing this term, you will get 1 by x into y is equal to, dividing this, you will get only sin x. Compare this with standard form. This is P, correct? This is Q. What is P? P is 1 by x. What is Q? Q is sin x. Then get the integrating factor. Integrating factor is what? Integration of P dx, or it is integration of, what is P? 1 by x. That is equal to e to the power of, integration of 1 by x is log x. So e log cancels, you will have only x. So integrating factor we got is x only. Using this, write the solution. The solution is y into IF is equal to integration of Q into IF into dx. Just substitute the values of Q and IF into what is IF? IF is x, right? Is equal to integral of Q. What is Q? It is sin x into IF. IF is x into dx plus c. How to integrate the right hand side? So the right hand side is of what? Product of two terms. Correct? In all the previous examples, will be only one term along with constant. Keeping the constant as it is, the single term whose integral is written directly. But here, the integral is having what? There are product of two terms, x into sin x or sin x into x. How to integrate this? As I mentioned in the previous class, by doing integration by parts, if there is a product of two terms and one is not the derivative of other, then you should go for integrating by parts. Integration by parts. There we have to select first and second function by the word I let. Correct? I let. Using that word, you select. This is what? This is algebraic. This is what? It is trigonometric. Correct. Which comes first? A or T? In the word I let, A comes first. Therefore, this will be the first term, first function. This will become second function. Right? So, according to the integration by parts, what the rule says? First function into integration of second into dx minus integral of bracket d by dx of first into integration of second into dx plus c. We have to use this integration by parts formula to get the integral of sin x into x. You just substitute which is first function. The first function is considered as x. Integration of second function is what? Sin x dx minus integral of, put a bracket, d by dx of what? First, that is x, into integration of what? Second. What is second? It is sin x into dx plus c. The right hand side is taken according to the standard form. Okay. Then just integrate it. The left side is what? X into y is equal to. Keep x as it is. What is integration of sin x? It is minus cos x, right? Minus integral of, put the bracket, differentiation of x is what? 1 into integration of sin x is what? Minus cos x into dx plus c. Okay? That is x into y is equal to minus x into cos x. This minus into this minus, minus into minus plus 1 into cos x is cos x into dx plus c. Right? xy is equal to minus x cos x plus integration of cos x is sin x plus c is the solution for the given differential equation. Right? Next problem of different type. So this is an important one. Solve dy by dx minus 2 by x into y is equal to 3x. Check this one. Is it in the standard form of linear differential equation? It is in the standard form of linear differential equation. Correct. What is standard form of linear differential equation? dy by dx plus y into p is equal to q, or p into y. Except y, you take whole thing as p. This is p, right? All right hand side should be taken as q. We just identified p and q. Okay, then get the integrating factor. Integrating factor is what? E to the power of integration of p dx, right? It is p into dx. What is p? Minus 2 divided by x dx, right? You take minus 2 outside. What is remaining? 1 by x dx. Integrate this. Minus 2 into log x e to the power of minus 2 log x. We cannot use our regular form e to the power of log a is equal to a because it is e to the power of minus 2 into log x. First, we have to simplify this minus 2. Use this one. N into log m is equal to what? Log of m power n. So, according to this, integrating factor becomes e to the power of log x to the power of minus 2. See, n is what? Index. So, this index become what? Power of the log of x, right? Now, e log get cancelled. It is e to x to the power of minus 2. It can also be taken as 1 by x square. So, this is known as integrating factor, right? Suppose here, if they give plus 3, so this becomes what? Solution. The solution of linear differential equation is, what is the solution? Y into if y into if is equal to integral of q into if into dx plus c. Replace the values of q and if. So y into if is equal to what? It is 1 by x square, right? Is equal to what is q? Q is 3x. Q is 3x into if is 1 by x square into dx plus c. It is y divided by x square is equal to, I am taking 3 outside, constant x into 1 by x square. This x cancel. What is remaining? 1 by x dx. What is integration of 1 by x? It is derivative of log x, right? 1 by x is derivative of log x. Therefore, integration of 1 by x is log x. 3 into log x plus c, right? The same way you can solve the problems. Dy by dx plus 3 by x into y is equal to 5x square. Dy by dx minus 3 by x into y is equal to 4 by x. These you can solve yourself. Okay. So these are important problems related to linear differential equation. Okay. So this is the syllabus according to our DTE board. So in this class we covered what is variable separable form, how to solve this, and what is linear differential equation, and how to solve the linear differential equation. Okay, so with this I am concluding my today's class. Thank you.